So the chapter basically talks about, let me just go back into that one. That here it talks about taking the working drawings for the upper level. Remember, there's an upper level and lower level in this building, and walking you through this upper level. That's what we're doing. So the first thing we'll do is, you guys are not doing it now, but you will be doing it later on with your friend Chad. As you start laying out your receptacle, we teach you estimating. We use Accubid and McCormick to do takeoff. So you have to start tabulating your material for installation and rough in and finishing and what's not. So I know we're not focusing on it right now, Matt, but in the spring, the last 6-7 weeks with me in the spring, you're going to take the projects that you've done in residential and commercial and industrial, and you're going to do a complete takeoff on it. Count every single receptacle and box and conduit and wire and connector that you did for this particular project, and come up with a dollar value, labor and material. That's called our estimating. If you work for engineering firms like Adam, and you never work for contractor, who cares? That we don't use it a lot. For those of you who want to work for contractors, that can make you a lot of money on one day, if you know how to do the takeoff. Select component to install an electrical water heater. In that upper level, there's a big 3-phase electrical water heaters, and we're going to talk about it, guys, in a few seconds here. Discuss advantages and disadvantages disadvantages between single and 3-phase power system. Obviously, 3-phase power system is superior to a single-phase power system. It gives you more power. It balances the system more. It's supposed to get you smaller conductor size. The disadvantage, if you lose one phase, you could burn equipment, right? If it's not properly sized. If you use a 3-phase, you could lose equipment, so or burn equipment. So that's what we're going to be talking about. Let's go, guys, and give you a tour of just the blueprint, how they did this blueprint calculation. So I'm going to go directly into this one. Okay, so the first floor, guys, is made out of the insurance office. Can you guys see that? And I give you a quick tour. Let's go for the insurance office. Let's go into room 1 right here. For insurance office room 2. Can you guys, Adam, you see how they're using all these fixtures? They're calling them G fixture. They have G fixture 1, 2, 3, and they're tying them to a receptacle. That's exactly what you guys are doing with your friend Chad. I want to bring to your attention, guys, the one in the center. Anybody can read this EM? What's the EM stand for? Brian? It's a fixture and has emergency on it, right? That's your emergency light. I'm sorry. EM, no, did they say BM? EM, my apology. EM is your emergency. So you have an emergency lighting fixture. Now, Matt and Karen, when you guys move your stuff, and Adam and Brian and Derek, when you guys move your stuff into Revit, you're going to ask me, Chad, where's your emergency light? Have anybody asked yet for an emergency light? It's coming when we go to Revit. You're going to be throwing a couple of emergency lights in the building. So keep this in mind. So that's the lighting system here. There's a couple of phone data outlets. Can you guys see them here? And a horn strobe right here. And for the receptacles, look what they did here. They have 4 quads, 3 quads in every area with a phone. See, these are offices. And these quads, guys, are coming from circuit 13, circuit 11, circuit 9. Anybody knows what IG next to each one of these circuit is? IG. Can you guys see the IG next to it? This is insulated ground. They want you to have an insulated ground. By the way, your technology circuits, my friend, that you're doing, the quads that you guys did in the project, is asking for the same thing, insulated ground. You guys circuit it, you're going to circuit receptacle, and if you read through the direction, it says the technology circuits must be fed from a dedicated neutral for every phase and an insulated ground. Insulated isolated ground. What this will get you guys will minimize the interference. An isolated ground, they have an isolated conductor from the receptacle on the wall through the panel all the way down to the surface. Who cares? It will minimize the corruption of the data for your electronic equipment. And if you're an insurance company and you're crunching a number and making money, that's a major thing. So, okay, so that's this area here. If you guys look at the insurance office, the other one, I don't know if you guys can see the floor boxes here. There's circuit 12 and 12 and 12. There's floor boxes with phone and data. Adam, this is what you guys are going to be doing with me for the open office. Instead of having a floor box, we're having a floor connection for the low voltage as well as the high voltage. So you guys can see them right here. They also have different lighting fixtures. I will bring to your attention, you guys are going to be doing this in a second here. Can you guys see, please, can you guys see this picture? It has G as fixture G. Can you guys see right next to it says A? Next to it is A, smaller A. Smaller A is the switch, the low voltage. It looks like a high voltage. The switch A here is going to be switching this particular fixture. This is a B on it, so switch B here will be switching this fixture. So I have 3 switches here that each one of them is assigned to a fixture. Any comments, any questions? Can you guys see that? Everybody can see that? That's what you're going to be doing with me. When you tag, when I say go tag it, you're going to tag it with a G, a capital letter for the fixture type, and a smaller letter for the switch, and a circuit. As a matter of fact, we're also going to do a circuit in our project. Okay, so that's what I want to show you in this area. A couple of receptacles. So a couple of power. There's also, it looks like a power strip right here. Can you guys see 4, 6, and 8 power strip along the wall here that they're putting right in here? Power strip. Okay, so that's this area. If you guys go to the bathrooms, in the bathrooms they have a couple of emergency E-light fixture with an emergency fixture right in the bathroom. Can you guys see that little emergency fixture with an occupancy sensor in the bathroom? Can you guys see that, how they did? This is exactly what you guys are going to be doing with your friend Chad. You will have an occupancy sensor, except it's not in the wall. Adam is going to be right in the ceiling. So they did the same thing. They have one receptacle for general purpose and the other receptacle for, I think, a water heater here, if I remember right. There's a space heater also here. So that's what they did for these bathrooms. If you go to the real estate office, they have different type of lights with an emergency light, guys, and different type of receptacles, the panels that feeds them and what's not. And also the beauty area here. I don't know if you guys can see, they have GFCI receptacles here. That's where you go groom yourself, Adam, and you just cut your hair. You sit right in here. Look how they have different type of fixture here, so you can look nice as you cut your hair. And they have a GFCI quad here, because it's next to the water, could be wet. And they have so they have general light and purpose light. E are the purpose light that shine right on top of you as they cut your hair. And the Fs are the general light in this area. And this is most likely where they wash your hair and what's not. So you can see the function of the place will dictate certain type of design. Can you guys see it? I can't emphasize this area here, the type of the light that they use in this area, because we need people will be sitting there and they're grooming their hair and what's not. And they need more specific lights so people look nice and what's not. Any comments, guys? Any questions? So that's basically what they're doing in this area. We have a water heater, I believe 1 through 13 is right here. So we'll talk about this one in a second here. That's what they have in this office. Main distribution elevator room is right here. There's an elevator control panel that feeds the elevator. So, Matt, what I always suggest, guys, when you read this chapter, and I know there's a lot of stuff to do, and rightfully so, you guys, you're going to be designers. Take this as another example of designing systems. So, when you end up working at Mishad, and they tell you we have a multi-occupancy building, and oh, by the way, there is an insurance office in it. Oh, yeah, here's an example that we did with Chad. Let's go start there, right? Do you guys see that? Hospital. Do you have an example for a hospital right now? If I ask you to design a hospital, do we have an example? No. When you go work for LRB Beckett and they do a hospital, the first thing they will do, you know what they do with you? They give you any good manager would do, and they will give you a set of blueprints of a hospital that they have just finished and say, hey, go review it. So you learn a few things. Does that make sense, guys? Does that make sense why we have these blueprints are so important? Now, is this the only way of doing this project? Absolutely not. This is one way. And say, if I've never designed an insurance office. If I have to design an insurance office, that probably would look at this one as an example. Take it to the owner and say, hey guys, here's what we're going to do for you. Do you have a standard in State Farm offices that you go all nationwide? Do you guys have a standard for your offices, type of fixtures? A lot of employers, guys, and vendors, they're so smart, like Target stores and what's not. They do have a blueprint for every single Target store in the nation and international. So when you go design a building for them, they will give you the blueprint. They say, this is what we want, Mr. Engineer, go make it happen. Now, the uneducated owners, they look at them and say, what type of receptacles you need in your office? They look at you as if that's your job. You should come up with it, right? Well, yeah, I'll come up with it. Here's an example. So it's nice to go to a customer with something in your hand and instead of say, oh, what do you guys want? Here's what we think you should have. Is this what you guys are looking for, or do you need something different? That's kind of my approach when it comes to every design problem. Okay, so that's what I wanted to show you guys. Let me see if we have any other specific things. So it talks about the insurance office. This is just reviewing what they did in the floor receptacle. I showed you guys the floor receptacle and the insurance office in the center. Special raceway installed in the two exterior walls. Provide for both electrical power and communication. That was, guys, in right here in the insurance office. Right in this area. I don't know if you guys can see it right here. So they have these raceway, multi-outlet assembly, that coming right in here for phone and data. There's 4, 6, and 8 circuit coming in here. Matt, this is exactly what you're looking at the wall right there. Can you see that receptacle? That's what they have there. Multiple receptacle. A raceway, multi-out assembly. Okay, so that's what they have here to provide power and data. Special circuit for personal computers. In the insurance office, I told you guys they have the computer. They have a special outlets with an insulated ground and luminaires. They have a special luminaire that cuts on the glare that coming out of the laptops, guys, as people work. These has louvers. You see them in offices, not like lenses, like these louvers. And as you put your laptop underneath them, it doesn't get you glare on the screen. Who cares? You can be more productive. Remember, we, electrical engineers, electrical designers, are in the business of solving problems for the customers. Wherever there's a problem, we need to solve it, right? If there's a glare, when that lady is doing or that man is doing the crunching numbers and they feel uncomfortable, they come to us to say, may you please solve this lighting problem for me, right? That's how they pay us. That's why we wear something. Otherwise, you know. So that's the most important thing. Okay, reception area provide combination of lighting system to provide the look for the clients. So they have a different type of reception. Computer rooms. In the computer room, guys, they also have a special surge protection for receptacles. Computer rooms have a lot of very expensive equipment. So they have surge protective devices. Lightning hit the transmission line. Instead of burning your electronic equipment, guess what? A surge resistor will pop and will most likely will protect your equipment. Special grounding system for so you can type, when you type Chad, it doesn't show Adam on the screen. So all these separate neutral, so you don't overload your neutral because of harmonic. Luminaire lenses have that listens the glare, so they have special louvers and lenses that cuts on the glare on the screen. So these are the stuff that they had. Again, reviewing what they did. So for isolated ground receptacle, guys, they have the receptacle slot that ground the equipment is completely isolated from the yoke. That's what isolated ground receptacle is. So connected to the special, so they connected to the grounding slot and with an insulated conductor that takes you all the way to the panel. Who cares? When you have an isolated ground receptacle and an isolated insulated conductor, guys, grounding conductor, it will minimize the interference with your electronic equipment. That's what you're trying to do. Surge protective feature receptacles to provide protection from lightning. We talked about that. 3 neutral conductors for so you solve the problem of nonlinear load. This is to talk about the takeoff, guys. Some tip for the taking off. Understand the system. You, Derek, my friend, in the spring, just around March, you will be taking your project and doing takeoff for it. So in order to take off, very few people, guys, will make it as estimators and very few people, because it's detail oriented, a lot of work and a lot of ability to understand. So when you're doing takeoff, you have to not only look at the 2D, you're going to look at the 3D. How am I going to pull this conduit from here up, over, cut through the beam and go down to the other equipment and estimate it? So if you're able to do that, take it off, estimate the work, you can make some good money. So. Okay, in the beauty area here, we have a special connection to the water heater. We have a water heater and small laundry and lighting circuits, guys. For the customers, the water heater circuit indicate that the circuit is to supply the electrical water heater. We talked about that one. Here's the water heater that they have, guys, in the beauty area. The size of the water heater, Adam, is not too big water heater, except it's three-phase. So the size of that water heater there for this area is 3,800 watt. It's a 208 and it's a single phase. So when you do the math, here's how you do the math. You get this, you multiply it by 1.25, you get this. And then you multiply it by 1.5 for the overcome protection device, you get this. So long story short, gentlemen, you end up with a circuit that's 30 amp and a water heater with two conductors number 10. Isn't that what we do in our house? That's what I have in my house. You know, for a 240. Same thing like 208 or 240, guys. I don't know how many of you were familiar with 240 water heaters, but this is a 208 water heater because we don't have 240. This is how it looks like, guys. The water heater. This happened to be actually three-phase, not the one that we did three-phase. If it's a three-phase, it's all what you need is you need a conductors here, so that will be 1.25. The overcome protection device 1.5. You multiply it by the amps and multiply it by the amps. You need a disconnect right here to disconnect the equipment, unless the equipment is within sight of the circuit breaker. Here's a washer and dryer, guys. They have a washer and dryer that happen to be single phase rated for this. When you do your calculation, the same thing, you take the volt amp divided by the voltage, multiply by 1.25 and size your equipment. So this is just going through a couple of loads that they have. So in a case like this, that will be a 25 amp circuit with number 10 conductor feeding it. We have a distribution panel board located in a small storage space, the main panel in the real estate office, and we have a control panel for the elevator. They have an elevator with the elevator machine and what's not equipment for it. For the toilets, guys, they have under-counter water heater for them, wall space heater, you saw that one, occupancy sensor to turn the light on and off, and it's fed from the owner panel because this is a multi-occupants building, and it's handicapped accessible. Now, Karen in 2014, NEC Code Book 2013, they're adding the American with Disability Act, certain requirement with the American with Disability Act into the National Electric Code. So make it easier for you to design for people with disability. So that's basically it, guys, in this this project. I cannot emphasize, Matt, my friend, I can't emphasize the importance of using this as another example for you guys. I always tell the students, there will be there's a lot of people that will be more than happy to make you guys a drafter for the rest of your life, right? Just draw lines. If that's what you want, you wasted your time with us here. All these examples, guys, are for you. I know it's a lot of stuff, a lot of material for you to get with you. Take the book, take the material. If you are faced with a problem like this, you have a solution for it. You know, all the projects that I did over the years, I have a copy of it for my own. So if I am faced with a hospital, here's a layout for a hospital, right? Because I forget, like you, I did it 10 years ago. I have a layout for a hospital I can start with. So these will be, guys, your samples that you take with you. You don't have to memorize all of them, but look at them, review them, understand as much as you could. Use them as samples. The last thing I'm gonna point out, guys, here, and then I'll let you I'll stop. Is I want to point out the emergency circuits. Here's an emergency light right here. So there's a bunch of emergency circuits, guys. There is an emergency light in this area here, an emergency light. You have to have emergency lights in every area. So these are your emergency common areas. So there is an emergency lighting fixture here. So there is an emergency where, if I can't see most of them, here's another emergency. Where's this? Can anybody look at the book and tell me? There's a bunch of emergencies that you have to pay attention to them, guys. Why am I pointing them? Because you guys are going to be doing them in a second for your friend Chad. Your emergency light. There's an emergency. We got that one. Where's the emergency in these? Chad. Okay, so there should be an emergency in each and every one of them. Bug eyes they're using. I can't see where they're using. So we have an emergency. So each one of these, in every area, guys, you have to have some type of an emergency light in every area. In every area. In the hallways too, you have to have an emergency light. The second thing I want to highlight, guys, is exit signs. Can you guys see where the exit signs? I will be asking you guys to provide an exit signs so you can direct the traffic outside the building upon the existence of a fire. Okay, before I leave this one, guys, here's another emergency light right here. Can you guys see that? I think there's also an emergency light right into here.
What are the requirements for like where those supposed to go?
Good point. Good point. The emergency lights are supposed to let the egress path. The egress path, guys, will be decided by Mr. Architects. For example, if this is an office, here's the exit of this room. Only one door, because that's a closet, so you don't need an exit sign. If you have to have an emergency light, you see that fixture right there? That 1, 2, that will be your emergency light, because upon the loss of power, that light will go on, it will lit the path, that's your egress path. So you guys will move in here, you can see the light is here, it directs you all the way to where? Out. So you have to design the egress path. I will walk you guys for the project that we have, I'll walk you through the egress path. So you have to establish, typically the architects establish the egress path in the building. I can tell you where you can guess all the hallways. Almost all the hallways are egress path because people have to go through them, right? And then open offices, you have to kind of establish the area in the middle. If you have an area in the middle, so that's where people come out into the middle, lit that area for them and channel them through the hallways all the way to the exits of the building. That's all what you need to lit. Unless you're in a hospital where you have other system, people's chest is open and they can't move. In general buildings, commercial buildings, it's typically hallways and areas. Right main door. The main door, you have to have a light so people can see where the main door is with exit signs that direct them to the outdoor. And for our project, my friends, I will walk you through where to put your emergency light. Otherwise, but I gave you a guess almost in the hallways, mainly the hallways. Mechanical rooms, we guys also like to have one. So we have an air handling unit running and you are working on it, all of a sudden the power went off. Really? I mean, it's dangerous, right? So you have to have mechanical rooms, you have one bathrooms, you're sitting in the bathroom doing your own business and the power went off, right? If you're like Chad, you'll panic. So they want to put light in the bathroom, emergency light in the bathroom, mechanical rooms. Think about any area that people can panic. Hallways need an emergency light. How much light do you need? The code requires you guys 1 foot candle. Remember, you were calculating based on 50 and 30 and what's not, right? In the hallways, we had 30 or something like this. Only you have to maintain 1 foot candle, enough for Karen to get up and see her way through to the door. Okay? And again, I'll walk you guys through this one. But for the time being, I want you to pay attention to the emergency light and the exit signs. For our project, Brian, these will be battery operated, because we do have a generator, but our generator is not an emergency generator. It's a backup generator, just to back up the power. So what we need to design is we have bug eyes, and we're going to put the bug eyes in certain areas and wire them from the same circuit, that sliding circuit that feeds that area. That's the requirement. If you have a bug eye, you know what a bug eye is, guys? Is that lighting fixture that has 2 heads on it with a battery. You put it right there, and you wire it from the same thread circuit that feeds these lights. So if Chad is to go accidentally, intentionally, or short something here, you lose the power, that bug eyes will notice that the power has been lost, and it will go on, or will turn on. Any comments, guys? Any questions? Can you guys assure me that you're going to review these to the best of your ability? The last thing, guys, is this is a water heater, really cool. I thought this is, I don't know how many of you guys have seen a 3-phase water heater. For the water heater, you need an overcap protection device. You need a disconnect within sight, unless the water, And look how they do them, phase A, phase B, phase C, and look what they have fuses, guys. They use a fuse blocks right here to fuse all these powers. So anyway, so that's how you, very easy, very simple, Adam. You take the amp, multiply by 1.25, size of conductor, multiply by 1.5, size of our computation device, and oh, by the way, make sure you have a little disconnect right next to the water heater that looks like this, or make sure the circuit breaker is within sight of the water heater. If it's not within sight, then you just put a disconnect right next to the water heater. These are three-phase water heaters. Same thing like single-phase water heaters, no difference. The only thing is the voltage that you use. Any comments, guys? Any questions? Any comments, my friends? Any questions? Okay. Would you guys be able to? Shall we finish the visual now, Chad? You overwhelmed a little bit? No. Shall we work on the visual? I'll be around to help you guys with the visual. I really would like you to, if we can cap the visual today and get it into Revit, then ask Adam. Dropping this fixture was not a whole lot. You drop the fixture and tag him, and it's not a whole lot.
I was going to ask you where I find a circle fixture.
Go to the instructor folder and see if you can have a round fixture there. And start lighting fixtures, and you'll find it there. A circle one. Any comments, guys? Any questions? Comments, questions? That's all I have for you. We're left, guys, with one chapter, chapter 9, which talk about raceways. I'll cover it tomorrow. I want to remind you, we do have a speaker tomorrow. Our lighting control guy, who did not show up, will be here tomorrow at 9 o'clock. So please count on an hour of that gentleman plus half an hour of your friend Chad yakking at you, so you can plan your day accordingly. Then my expectation by tomorrow, guys, that you will have things done with Revit, with the visual imported into Revit, and you have started Revit. If you're done, that will be great. You got your A's. If you're not done, you get your D's. Oops, did I say that? Do a good job on visual. I know it's new software, guys, so but keep in mind we still have next week to work on lighting, but it goes fast. If you can cap it this week, move to Revit, you should be able to be in a good shape. So cool. Yes, there.
I had a question just about the exterior.
Okay. Now remember, the exterior is not due until next week.
Oh, so we're just doing interior this week?
Yes. Yes.
Oh, okay.
Yes. Everybody understand that? Exterior is due next week. We are focused on the interior and importing them. I can answer your question in a second here, but
No, I mean,
yeah.
next week,
Yeah. Oh, yeah. Otherwise, it'll be way too much. So finish the interior, export to CAD, to Revit, start layout, and then next week we will open the exterior and finish that. So we have time. We have time. Thank you, guys. Yeah. Give me 1 second here. Sec.